math learners. Our lesson for today is about the graph of exponential function. This is the Learning Pocket concept map, and we are going to focus only on the graphs of exponential function. The learning objectives are: you are going to sketch the graph of exponential function. Transform the graph of exponential function by shifting it vertically or horizontally. And identify the properties of the exponential function. These are examples of the graphs of exponential functions. The first one is the graph of f of x is equal to 2 raised to x. The second one is the graph of f of x is equal to 0.5 raised to x, or can be written as 1/2 raised to x, or 2 raised to negative x. And the third example is a combination of the graphs of y is equal to 0.5 raised to x, y is equal to 3 to the x, and y is equal to 2 raised to x. Notice the curve of y is equal to 3 to the x is steeper than y is equal to 2 raised to x. Let us have the properties of the exponential functions. Let us have first the properties of the function equals to a raised to x when a is greater than 1. This is the graph of f of x is equal to 2 raised to x. The value of a is 2, and 2 is greater than 1. The first property is the domain is the set of real numbers, or D is equal to the set of x such that x is an element of real number. The range is the set of real numbers greater than 0, or R is equal to the set of y such that y is greater than 0. Meaning you cannot use the values of y less than 0 because the graph will not cross the x-axis. The third one, y-intercept is equal to 1. The graph passes through at point 0, 1. It has no x-intercept because the graph does not cross the x-axis. The graph is increasing if a is greater than 1. As the value of x increases, the value of y increases exponentially. X-axis, or the y is equal to 0, is the horizontal asymptote. The graph is asymptotic to the x-axis as x approaches negative infinity, which means it will get closer to 0 but never touches the x-axis. The graph is continuous and it is smooth. Next, let us have the properties of the function equals to a raised to x when a is between 0 and 1. So this is the graph of f of x is equal to 0.5 or 1/2 raised to x. So 1/2 is between 0 and 1. First property. The domain is the set of real numbers, or D is equal to the set of x such that x is an element of real number. The range is the set of real numbers greater than 0, or R is equal to the set of y such that y is greater than 0. The y-intercept is equal to 1. The graph passes at point 0, 1. So this point. It has no x-intercept. The graph is decreasing if a is between 0 and 1. As the value of x increases, the value of y decreases exponentially. X-axis or y is equal to 0 is the horizontal asymptote. The graph is asymptotic to the x-axis as x approaches negative infinity, which means it will get closer to 0 but never touches the x-axis. And the graph is continuous and it is smooth. Let us have the steps in sketching the graph of exponential function. Step 1, construct the table of values of the function. Step 2, plot the points in the Cartesian plane. Step 3, connect the points with a curved line. Step 4, give the properties of the function. And take note, you have to label the graph completely. Let us have example number 1. Graph the exponential function f of x is equal to 2 raised to x. Let us have now the graph of f of x is equal to 2 raised to x. For step 1, we have to construct the table of values of the function. And the assigned values of x are negative 2, negative 1, 0, and 1. And the corresponding values of y are 0.25, 0.5, 1, 2, and 4. I will give you only one example on how to get the value of y. So at x is equal to negative 2. So all you have to do is to replace negative 2 to x. We have now 2 raised to exponent 2. And simplify, this will become 1 over 2 squared. And 1 over 2 squared is equivalent to 1/4. And you can simplify, you can change this into decimal form. You have 0.25. That is why y is equal to 0.25. For step 2, you have to plot the points in the Cartesian plane. And these are the coordinates of the points. Let us plot now the points. There, you have the first point. Next. 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 And we have now the last point with coordinates 2 and 4. For step 3, all you have to do is to connect the points with a curved line. So, with the 5 points, just connect with a curved line. For step 4, you have to give the properties of the function 2 raised to x. For the domain, you have the set of x such that x is an element of real number, meaning you can use all the values of x. For the range, you have the set of y such that y is greater than 0, because the graph did not cross the x-axis, so you cannot use the negative y values. The y-intercept is equal to 1, passing through the point with coordinates 0, 1. So this point. It has no x-intercept if a is greater than 1. As the value of x increases, the value of y increases exponentially. X-axis or y is equal to 0 is the horizontal asymptote. The graph is asymptotic to the x-axis. The graph is continuous and it is smooth. And take note, the intercepts, the 0, which is equivalent to the x-intercept, and asymptote of the given function can be determined by graph inspection or by using algebraic method. And remember, the curve of the function 2 raised to x comes very close to the x-axis but never touches it. The x-axis is an asymptote for every exponential function. F of x is always positive, so the range of the function is the set of positive numbers, whereas the domain is the set of real numbers as shown in the graph of f of x is equal to 2 raised to x. And f of x is equal to a raised to x generally has no vertical asymptotes. since x may have any value, it has only horizontal asymptote. Do you have questions? If there is none, let's proceed. Let us have example number 2. Graph the exponential function f of x is equal to 1/2 raised to x, or f of x is equal to 0.5 raised to x. Let us graph now. F of x is equal to 1/2 raised to x. So 1/2 is between 0 and 1. So the table of values, we have x is equal to -2, -1, 0, 2. And y is equal to 4, 2, 1, 0.25. So, for example, in order to get y, you have to replace x by a -2. Then, you distribute -2 to the numerator 1 and to the denominator 2. And then simplify the negative exponents. You can interchange the position. The numerator will be placed at the denominator part, and the denominator will be placed at the numerator part, and then you change the sign to its opposite sign. So you will have now 2 squared, so 2 becomes now positive, and 1 squared. So the -2 becomes positive 2. Then simplify, 2 squared is 4, 1 squared is 1. So f to the -2 is equal to 4, or y is equal to 4. That is why we have y is equal to 4 when x is -2. So let us have another graph and then connect with a curve. So there you have -2, 4, -1, 2, 0, 1, 2, 0.25, and then with a smooth curve. Let us identify now the properties. The domain is equal to the set of x such that x is the element of real number. The range is equal to the set of y such that y is greater than 0, because still the graph did not cross the x-axis. The y-intercept is equal to 1, passing through the point with coordinate 0, 1. It has no x-intercept. The graph is decreasing if a is between 0 and 1. As the value of x increases, the value of y decreases exponentially. X-axis, or y is equal to 0, is the horizontal asymptote. The graph is asymptotic to the x-axis. The graph is continuous and it is smooth. And then you have to place arrowheads on both ends of the graph, because this will mean that the graph can still be extended. So this is now the graph of f of x is equal to 1/2 raised to x. Next, let us have the graph of the exponential functions. F of x is equal to 2 raised to x, and f of x is equal to 1/2 raised to x. For the table of values for the first function, 2 raised to x, we have -2, 0.25, 0, 1, and so on. For the function is equal to 1/2 raised to x, we have -2, 4, -1, 2, and so on. So let us have now the graph. For the first one, we will have to plot the points of 2 raised to x and then connect with a curve. And then let us use another color for the graph of 1/2 raised to x and then connect. Okay, there. The two graphs intersect at 0, 1. And do not forget to place arrowheads on both ends, because the graph can still be extended. And the red one is the graph of the function 1/2 raised to x. The blue one is the graph of the function 2 raised to x. And do not forget to label the y-axis with y, x-axis with x, and our x-axis becomes the horizontal asymptote y is equal to 0. Next, let us have the graphing of exponential functions with a vertical shift. The first transformation occurs when we add a constant c to the parent function. F of x is equal to a raised to x, giving us a vertical shift c units in the same direction as the sign. The second transformation occurs when we subtract a constant c to the parent function f of x is equal to a raised to x, giving us a vertical shift c units in the same direction as the sign. Take note, a parent function or original function is the simplest function that still satisfies the definition of a certain type of function. Let us have now the steps in graphing a vertical shift. First step, you have to graph the parent function or the original function f of x is equal to 2 raised to x. The horizontal asymptote is y is equal to 0. So, let us just use 3 points with negative 2, 0.25, 0, 1, 2, 4. So let us plot the points. Starting with the horizontal asymptote, then the first point, second point, then the third point, and then connect. So this is the y-intercept. This blue one is the graph of the parent function 2 raised to x. Then let us graph two vertical shifts alongside using c is equal to 3. So the first one, the upward shift, the second function given is g of x is equal to 2 raised to x plus 3. And the horizontal asymptote is y is equal to 3. The table of values, we have negative 2, 3.25, 0, 4, 2, 7. So, let us look at the graph of the second function. There you have the horizontal asymptote. And plotting the 3 points. And then connect with a curve. So, if you notice, from here, it's 1, 2, 3. So the distance is equivalent to 3. So from here, you shift 3 units up. And then for the second shift, the downward shift, we have the third function, 2 raised to x minus 3. The horizontal asymptote now is y is equal to negative 3. The table of values, we have negative 2, with negative 2.75, 0, negative 2, 3, and 5. So let us have the graph of the third function now. Y is equal to negative 3 as the horizontal asymptote. Plotting the points. And then connect with a curve. There, as you can see, from 0, 1, 1, 2, 3. You shifted 3 units down. So this is an example of a vertical shift. And observe the results of shifting f of x is equal to 2 raised to x vertically. Then when a function is shifted up 3 units, giving the second function 2 raised to x plus 3, we have the domain x is equal to the set of x such that x is an element of real number, so it remains unchanged. But for the range, we have the set of y such that y is greater than 3. The y-intercept shifts up 3 units to 0, 4. So here. So from here, 1, 2, 3. So at 0, 4. The horizontal asymptote shifts up to 3 units to y is equal to 3. From here, we have now the horizontal asymptote y is equal to Then another observation, when the function is shifted 3 units down, giving the third function, h of x is equal to 2 raised to x minus 3, the domain remains unchanged. But the range now is equal to the set of y such that y is greater than negative 3. So look at the graph. This is negative 3. You can use only the values greater than negative 3. The horizontal asymptote now is equivalent to y equals to negative 3 because from the original you shifted down 3 units. And take note, a function of the form f of x is equal to a raised to x plus c always has a horizontal asymptote at y is equal to c. So whatever the value of c, that is your horizontal asymptote. So let us look at this. C is positive 3. That is why our horizontal asymptote is positive 3. And here it's negative 3. So that is why our horizontal asymptote is negative 3. Here the constant is 0. That is why the horizontal asymptote is 0. You have questions? There is none. Let's proceed. Let us have now graphing a horizontal shift. The first transformation occurs when we add a constant c to the exponent of the parent function. F of x is equal to a raised to x, giving us a horizontal shift c units in the opposite direction of the sign. And the second transformation occurs when we subtract a constant c from the exponent of the parent function, giving us a horizontal shift c units in the opposite direction of the sign. So let us have an example. So first, we have to graph the parent function 2 raised to x. This is the table of values. X is negative 2, y is 0.25, and so on. So let us plot the points. First point, the second point, and the third point, and then connect with a curve. So that is the graph of the parent function. Next, we have to graph the second function. G of x is equal to 2 raised to x, but this time we will add 3 to the exponent. And this is the table of values. So x now is negative 5 with y 0.25, negative 3, 1, 0, and 8 for y. So let us take a look at the graph of the second function. So that's the first point, second point, third point, and then connect. So as you can see, this is x plus 3. From this point, you move 3 units to the left. So meaning to the opposite direction. So if you have positive 3, you move 3 units to the left. And then graph the third function, h of x is equal to 2 raised to x minus 3. So the table of values we have, if x is 0, then y is equal to 0.125 or 0.13. Then 3, the value of y is 1. And if x is 5, the value of y is 4. Let us take a look at the graph. So, plotting the 3 points. First point, then the second point, and then connect. So, if you notice, if you have minus 3, you move 3 units to the right from the original function. 1, 2, 3. It's the opposite direction. So when it's plus 3, you move to the left 3 units. When you have negative 3, you move 3 units to the right. And the horizontal asymptote is equal to y equals 0 or the x-axis. And observe the results of shifting the parent function horizontally. When the function is shifted left 3 units to the second function, 2 raised to x plus 3, the domain remains unchanged. but the range is equal to the set of y such that y is greater than 0. Horizontal asymptote is y is equal to 0 remains unchanged. The y-intercept shifts such that the y-intercept is equal to 8 at point with coordinate 0, 8. So this is the function. This is now the y-intercept. From 0, 1, we have now 0, 8. And when the function is shifted right 3 units to the third function, which is 2 to the x minus 3, the y-intercept is equal to 1, 8 at point 0, 1, 8, or with coordinate 0 and 0 0.13. This one. From 0, 1, so we have now the y-intercept 0 and 0 0.13. The solutions for the y-intercept, let x is equal to 0. So given the second function with exponent x plus 3, this is the g of x, then you can simplify 2 raised to exponent 3 and then another base 2 raised to exponent x. So you can expand the given expression into this form. And 2 cubed is equal to 8. X is equal to 0, replace x by 0, then 2 exponent 0 is 1. 8 times 1 is equal to 8. That is how we take 8 as the y-intercept. And then for the third function with exponent x minus 3, you can simplify the expression, expand this by having 2 to the negative of 3 times 2 raised to x. And change x to 0. So 2 exponent 0 is 1. And 2 to the negative of 3 is equivalent to 1 over 2 raised to 3. And this is equivalent to 1/8. And 1/8 times 1 is 1/8. And you can change this to decimal, equivalent to 0.125, or y is equal to 0.13. So this is how to solve the y-intercept of the third function. So in graphing a horizontal shift, first we have to graph the parent function. So this blue graph is the parent function. Let us graph 2 horizontal shifts alongside it using c is equal to 3. Shift left given the second function with exponent x plus 3. And then shift right using the third function with exponent x minus 3. So this brown graph is the second function and this graph is the third function. So this is how to graph using a horizontal shift. Do you have questions? If there is none, then see you next time. Bye!